All right, if we look at 14.10, so we're asked whether the compound could be a what? We've got a ketone, an alcohol, a carboxylic acid, primary amine, or secondary amine. Well, the first thing that I notice is that in A, if you draw a line above 3,000, and if you draw a line above 1,500, could anybody make a guess as to what's going on or what kind of functional group we might have in A? Yeah, absolutely. My students are all saying a ketone. Yeah. Why? Because we know if there's nothing above 3,000 reciprocal centimeters, it's not an alcohol, it's not a carboxylic acid, it's not a primary amine, and it's not a secondary amine. It's none of those things. However, we do have a strong absorbance here around 1700 for a carbonyl. Therefore, it must be a ketone. It can't be any of those other things. If we move on to B, so let's move down to B. I mean, you could always start by drawing your line at 1500. And then if you want to, you can draw one around 3,000. That can come in handy. But anyhow, what about B? Does anybody recognize anything in B or have a hunch? I'd say it's pretty abundantly clear. Yeah, absolutely. Here we have the huge OH stretch for a carboxylic acid. I mean, this one's just gigantic. It goes on forever. We have the carbonyl around 1700. For a carboxylic acid, we also have the carbon oxygen stretch, which is probably here. This is the CO stretch right there. And so this is a carboxylic acid. So we'll just draw the condensed structure like that. Let's move on to C. C isn't as easy, I don't think, but I'll see if my students have an idea. Does anybody have an idea in C? C is trickier. Yeah, somebody's saying an amine, and I agree. Um, if you look here, there's no carbonyl. Okay, so it's not a ketone, it's not a carboxylic acid. We do have some stretching right here, but it's like there's one peak, okay, one peak, and it's right at around 3,400 reciprocal centimeters, okay, and there's only one of them, so this is probably a secondary amine. So we'll put here secondary amine, okay, and this is the NH stretch from a secondary amine. What about D? I'll leave it up to my students. Again, if anybody has a suggestion. Yeah, another amine. Yep, absolutely. Here we have another amine. So if I just move this down, come on, ruler. There we go. All right, so here we have, you notice that there's two signals here. So this would be a primary amine. Okay, and these are the NH stretches. And those are around 3350. So it's around 3350 and 3450 reciprocal centimeters, right? There's no carbonyl. So if this is 1700, there is no carbonyl present. So that's a primary amine. Next one, what about in E? Yeah, I tend to agree with all my students that are saying a ketone. Right, there's nothing up here, no signals or signals, okay? But we do have the big carbonyl here. This is the carbonyl stretch. Okay, so this is a ketone. And then we have one more. What about the last one? Yeah, I think the last one's an alcohol as well. I think you're 100% correct. We draw a line here. We have the OH stretch, right? So this is an alcohol. Okay. And there you have it, my friends. So the OH stretch of an alcohol is where? It's between 3,600 and 3,200 roughly. So 3,600 to 3,200 reciprocal centimeters. And there you go. No carbonyl. Then we also have the carbon-oxygen stretch. All right, there you go. So we have an alcohol with that one. All right, let's move on to the next question. This is question 14.12. You're given a bunch of interesting compounds here, and you get some functional groups. So here we have an alkene, we have an alcohol, we have two carboxylic acids in the same molecule, we have another amine, and then we have an ester over here. All right, just by looking at all of the spectra, I'm going to ask my students first, is there any one that you were able to figure out quickly? There's no way for me to squeeze them all on the screen here, but is there anyone that was abundantly clear to you? Anyone that was even more clear than that? Yeah, thanks, Kelly. I would go with D. Yep, with D, I'd start there. So what do you think D is, Kelly? Absolutely. So this is the oxygen-hydrogen stretch right here. Okay, there's no carbonyl. Right, this is our CO stretch, single bond. So this is the alcohol, and there's only one alcohol in the problem. So which is it? It's this alcohol here. There we go. We've got the alcohol. Is there another one that's abundantly clear to everybody? I'd say there's another one that's a second lowest hanging fruit, maybe. Is there one that's just boom, just you see it right away? Yeah, E, absolutely. Right, you have this huge oxygen hydrogen stretch here in E. You've also got the carbonyl, and you've got the carbon oxygen stretch. So this is the carboxylic acid. This is called malonic acid. And if you studied biology, you might have seen malonic acid before. Okay, so we got the first two, and then we got rid of this one, and we got rid of this one. All right, I'll throw it out there to my students. Sorry if I didn't read everything, but is there anything else? You know, I noticed something in B. Is there anything that somebody notices in B right away in this spectrum? There's something big in B. I'm going to turn on B. The thing I notice in B is the carbonyl. Yes. In B, I have a carbonyl, right? I also have a carbon-oxygen stretch here, and I have no signals up here. All right, so that tells me out of everything on here, it must be the ester. So we can cross the ester off. It must be this ester. Okay, so now we get the ester out of here. Now we've got the amine, the alkene, and the alkane. Which one would be the amine? Must be this one down here, right? This would be a primary amine. That's right, because we've got two peaks here. So this is a primary amine. Yes, absolutely. So these are the NH stretches. Okay, so we could draw in the amine. So which is this guy. Okay, there we go. And how many are left? I'm sorry, I can't even see them all. Oh, we got A and C. Blah, blah, blah. Well, if you draw a line on A and C, let me show you how I would do these. You draw a line at 3,000 reciprocal centimeters for both. This one here, and then you do the same thing here. You notice there's a big difference above 3,000 reciprocal centimeters, isn't there? Because you do have a signal right here. right, for this one. And this is an sp2 carbon-hydrogen stretch. Remember, around 3,100 reciprocal centimeters. This means this is our alkene. And the structure of the alkene is this. Come on, you. Stop moving. Like that. All right. You see that we also have the signal for the carbon-carbon double bond stretch here. Okay, because if you look at the table for an alkene, we saw that the carbon-carbon double bond stretch was around 1630. So if I take my ruler, I'll use the yellow pen. And if I take my ruler, so if I go 1630, that's right around here. So there you go, right on the nose. So we could write that down. It's around 1630 reciprocal centimeters. And then in the last one, I think Mackenzie told me a while ago that C was the alkane. There's nothing up here. There's no carbonyl, right? There's no triple bond. There's nothing, okay? So this would be the alkane, which is called pentane. And there you go. We solved all of them just like that. If we go back to our notes or back to our slides, there's one more section in this chapter that deals with infrared spectroscopy, and that's section 14.7. It says, how would you use IR to distinguish between two compounds? Because oftentimes organic chemists will do reactions where we convert one functional group into another. Like below here, you see that we're starting it with an alcohol, and we're converting it into a ketone after an oxidation reaction. So how would you differentiate between these two compounds? Well, you could use infrared spectroscopy to follow this reaction very quickly, because here you would see the oxygen-hydrogen stretch, right? And what you would see is as the reaction progresses, that OH stretch, all those absorbances would disappear, and you'd start to get a carbonyl. So you'd get a carbonyl at around 1700 reciprocal centimeters. And then this stretch for the alcohol, which is in between 3600 and 3200 reciprocal centimeters, that would disappear. So this would go away, and then this would start to appear like that. So it's kind of a fun way to follow a reaction, is to use infrared spectroscopy.